scenario would you use log, cosine, or sine in?
Okay, here's the scenario. First of all, let's list that law. Now, let me get clear here a little bit. You're just starting trig, right?
Yes.
Other than the trig you've had in previous years.
Yeah, so this is a bit of review.
Okay, that's why you're reviewing the law of sines. Okay. What the law of sines says is that in any triangle, this ratio is a constant, regardless of which side and which angle you're looking at. Doesn't have to be a right triangle. A,
so
B.
You use the law of sines when it's not a right triangle?
Yes. In other words, it doesn't have to be a right triangle. If this little side is C, and this little side is A, and this side is B, then no matter what the angles are in that triangle, I can say that the sine of this big angle A divided by its opposite side is a constant. It's the same as the sine of that angle divided by its side, which is the same as the sine of that angle divided by that side. So it's very useful if you have a situation where you have one of those relationships. In other words, if I give you a triangle and I say that's 30 degrees and that's 8 and this is 40 degrees, this allows me to solve the triangle. In other words, I only need one relationship, and I've got it right there. It means the sine of 30 degrees, which is 1/2, divided by 8 is the same as the sine of 40 degrees divided by this side right here.
Yeah.
So
okay.
I can solve.
And then when it's a right triangle, you can just do like that SL110514 thing?
Yeah, you don't need it so much on right triangles because, exactly, right triangles you have the ability to use the definition of the trig function to solve it. In other words, if I give you a right triangle and that's 30 degrees and this is 2, well, I automatically know this is 60. And so I can figure out everything else based on that. In other words, the tangent of 60 is this side divided by 2. So I can solve for x. And then once I've solved for x, I can solve for z. So I can completely solve the triangle, always, right triangles, without using the law of sines. The law of sines actually fit. They do. In other words, it works, but you don't need it. Because the sine of 90 degrees is always 1. So the sine of this angle divided by z is always going to be 1 over z. And these work in reverse. In other words, I can put the a on top and the sine a in the bottom as long as I do the same with all of them.
Okay.
Okay?
And then,
now, there is one particularly difficult case that you have to be aware of. In fact, it's the only difficulty in this whole section, and that is the case of the ambiguous law of sines. Have you talked about that yet?
no.
I'm sure you will. Here, let me see if I can approximate what the problem is. If I have this triangle, let me erase that. You don't need that up there anymore. This side is 10, this side is 8, this angle is 40 degrees. Notice that we have side-side angle, which is not enough to prove similarity or congruency. And notice that I can use the law of sines here, right?
Mm-hmm.
In other words, I can say the sine of 40 degrees divided by 8 equals the sine of C divided by 10, which allows me to solve for that angle C. But guess what? There might be two solutions. In other words, let me draw this triangle slightly differently. Where this is still 40 degrees. This is still 10, and that's still 8. And this is allowable. This is called the ambiguous case of the law of sines, meaning that there are certain triangles, and it all comes down to the relationship between these two numbers here. There are certain triangles that don't have just one solution. In other words, when you're solving triangles, they usually give you three pieces. They give you one angle and two sides. Well, most of the time, this will produce a unique triangle only. But occasionally, if the relationship is right, you can get this triangle, but you can also get this triangle over here. And the difference between these two is this angle for C is complementary to this angle. If this angle was, say, 50 degrees, then this angle C is 130 degrees. And that makes the law of sines work. In other words, this one says that the sine of 50 degrees divided by 10 equals the sine of 40 degrees divided by 8. And over here, this one says the sine of 40 degrees divided by 8 equals the sine of 130 degrees divided by 10. Well, why is that true? It's because the sine of 130 degrees is the same number as the sine of 50. So there's no conflict. Now, determining, there's a hard way and an easy way to determine whether or not you have the ambiguous case of the law of sines. I am a firm believer that the easy way is the way to go, not the hard way. And believe me, there's a tremendous difference between the two ways. One way requires you to memorize a whole page of stuff. The other way is you just attempt to solve it, and your answer lets you know whether you have two solutions or one.
Okay.
And the best way to explain myself would be with a problem. This may or may not produce an ambiguous triangle. I know that one of these does, either the 8 there and the 10 there and the 40 degrees, or vice versa. Since you're not there yet, do they have they given you any problems of solving the triangle?
Yeah, but I don't know that they're ambiguous.
Well, I can tell. Let's do one. Give me a couple, and I'll be able to tell. And in fact, it's in the solving of it that we figure out whether there's an ambiguous or not. So let's try one. And it's got to be side angle. Pick one that's side angle, since we only got like 15 minutes.
Okay. So this one is A on the left, and then B is like on the top, middle, and then C on the right.
Okay. It doesn't really matter how it's oriented. Just give me the angle and the two sides they give you.
So AB is, they just have X. And then BC is 7 centimeters. And then AC is 12 centimeters. And theta sine is on angle.
Is it an angle? Do you have an angle?
Yeah, angle ABC is the theta. And then it says sine of theta equals 0.98 0.98481.
What was that number again?
0.98489848
That's enough, I think, decimals. Okay, we can actually solve this using the law of sines, so let's do it. What's the law of sines going to be? In other words, what you need to use the law of sines is you need this, and you need the opposite side of theta, which in this case is 12. So I'm going to be able to say that the sine of theta divided by 12 equals the sine of A divided by 7 equals the sine of C divided by X. Okay? Now, let's work with just this part, because they've given us this. So there's only one variable to solve for, and that's A. Okay? So, here's what I'm going to write. 0.9848, that's the sine of theta, divided by 12, equals the sine of A divided by 7. Now let's figure out what A has to be. Do you have a calculator in front of you?
Yeah.
Tell me what sine of A equals.
Sine of A equals 0.5745.
That's enough. Okay, now tell me what A equals, and here's where you use the ambiguous. In other words, take the inverse sine of 0.574.
35.
How much?
35.065.
Okay. At this point, we try to figure out, can A also be complementary to that? In other words, are there two solutions here? This is definitely one solution. And in other words, we can solve for theta too. Take the inverse of that number there, and we'll put a number in here for theta. But this tells us that that's 35 degrees. I'm going to round everything off here. Take the inverse sine of 0.9848. Just, it's more understandable that way. What's that angle?
Let's see. 79.99.
80?
No, 70. Oh, yeah, 80.
Okay, so that's 80. This is 35. This has to be 65. Okay? We've got all three angles. We've got two sides, and I can figure out this third side easily by using the law of sines again. Right? Okay, hold on. Let's go back. When we solved for A of 35 degrees, there's actually a second possible solution, and that's the complementary of that. 144 degrees, or 145 degrees. We'll call it 35 degrees. In other words, A could be 35 degrees, but it might also be 145 degrees. Can it be 145 degrees? Not as long as B is 80. And that's how you tell, is you add this angle, supplementary of this, to the other known angle in the triangle, which is 80, and you can tell that this is not a possible solution. Therefore, this triangle does not qualify for the ambiguous case. It would if this supplementary angle added to the other known angle was less than 180. Then you would have two results, possible results. and they would each give you a different x.
And then to find, x, I would just kind of repeat the process.
Well, now we know that this ratio is the standard ratio for this triangle, and that has to equal sine of c over x. Well, now we know what c is, 65. So it's the sine of 65 divided by x equals 0.9848 divided by 12. So you can easily solve for x. When you have the ambiguous case, it's usually when this angle is smaller. First of all, if this angle here is over 90 degrees, you can't have the ambiguous case. That's one of the conditions. In order to have the ambiguous case of the law of sines, you have to, the known angle that you have has to be less than 90. And in fact, most of the time it has to be pretty small. It has to be like 35 or 40. Because when you get this supplementary angle, it's always going to be big. And when you add this to the known angle, it has to come out to be less than 180 for you to have the ambiguous case of the law of sines. If it comes out to greater than 180, then you don't have it. And you can just solve it as a single solution.
Okay.
You know, I wish we had one that we knew for sure was the ambiguous case. I think I can do one real quick. Let's try it if you have a minute. Unless you have others that you want to talk about.
No, this is good.
Let's do this right here. Pretty sure this is the ambiguous case here. Okay, so let's solve this triangle. Okay, so I can say that the sine of 30 degrees divided by 8 equals the sine of 60, the sine of c divided by 10. So let's solve for c. We've got, that's 1/2. Sine is 1/2, so it's 10/16. 5/8 is equal to the sine of c. Take the inverse. What is c equal to? What's the inverse sine of 5/8?
38.68.
Round it off, 38. What's the supplementary angle also that's possible? 142, right? Now, we check by adding 142 to 30. That's less than 180. That means we can have two different triangles. I could draw this triangle, and I'm going to draw it both ways. Here's the second solution. That angle is still 30. This side is still 10. This side is still 8. In other words, we still have the same three pieces of information for both of these triangles. But in this case, this one is 38. That leaves this one to be 112. My math is correct, yeah. Down here, this one is 142, and leaves that one to be 8.
Yeah.
And notice that this side length is going to be different than this one up here. That will be whatever it is when we use the law of sines to solve it. But this triangle also fits those three starting conditions, that angle A is 30, this side is 10, the side opposite angle A is 8. And that does produce the ambiguous case. So the moral of the story is that whenever you solve for C, always write the supplementary angle and see if that's a possible answer also.
Okay.
And it's real easy. You just add it to the only known angle in the triangle, which is 30. At this point, the only angle I know for sure is 30. And as long as that's 30 and this thing is 142, that allows a third angle.
Yeah.
And this is by far the easiest way to check for the law of sine, for the ambiguous case. Now the downside is you always have to check this. Even when it doesn't, well, it doesn't, if this angle is greater than 90, you don't have to check it. But if this angle is less than 90 and you have angle side side, then you essentially have to do this step every time, just to see if you have a possible one.
Okay.
All right. Sarah, you good to go?
Yep.
Because I know when you make a half-hour session, that's fine, but I don't have anything afterwards, and so if you needed 45 minutes, I'm always willing to give you extra time. You know, I would charge you for 45 minutes, but don't feel like you have to cut it off at a half hour.
Well, yeah, I think for this, I'm fine, but
okay.
Yeah, the next time.
Yeah, if it ever happens, just be aware of that. Okay. And sometimes I can do that, sometimes I can't. In other words, if I had an 8:30 appointment, I wouldn't be able to do that, but tonight I don't have it, so.
Yeah, okay.
All right? All right. I will talk to you next time.
All right, thank you.
You're welcome. Bye-bye.
Bye.